Have you ever seen something that just seems to break the laws of physics? Well, today we're pulling back the curtain on one of the coolest optical toys out there. We're going to unmask the magic and see exactly how the trick is done.
Okay, so take a look at this. This little device is called a Mirascope, and floating right there in that opening is a perfect three-dimensional frog. It looks so real, so solid, you'd swear you could just reach out and pick it up. Your eyes are telling you it's right there. But when you actually try, poof, your fingers go right through it. There's nothing there. It's a ghost. A perfect little illusion, basically a hologram made with nothing more than light and some cleverly placed mirrors. So what in the world is going on here?
Right? How does this thing conjure up a solid-looking object out of thin air? To solve this little puzzle, we've got to go back to basics. We need to understand the science behind the magic trick.
So before we can tackle this mind-bending illusion, let's take a quick step back and remember how we see anything in just a simple, everyday, flat mirror.
When you look at something in a mirror, light from that object bounces off the mirror and zips into your eye. Now, here's the trick your brain plays on you. Your brain doesn't really process the bounce. It just assumes light always travels in a straight line. So it traces those light rays backward to a point behind the mirror where they seem to originate. And voila, that's what we call a virtual image.
That's cool and all, but it's not going to get us our floating frog. A virtual image behind a mirror won't help us create a real-looking object floating in front of one. No way. For that, we need a mirror with a very, very special, almost magical shape.
And here it is. This is the hero of our story, the parabolic mirror. It's not flat. It's a precisely curved dish. And that curve, well, that's where all the magic happens. So what's its superpower? It has this incredible ability. It can take a whole bunch of parallel light rays that hit it and reflect every single one of them so they all meet at one tiny single point. And that one special point has a name, the focus. Remember that word, because it is absolutely crucial for creating our illusion. All right, now let's crack open the Mirascope, because the real secret isn't just one parabolic mirror, it's two of them facing each other. The real object, our little frog, is actually sitting hidden on the bottom mirror, and that hole you see is in the top one.
So what happens to the light from that hidden frog? Let's follow a single ray on its wild ride. First, a ray of light leaves the frog and shoots up, hitting the top mirror. Then, it gets reflected down to the bottom mirror. And finally, it bounces off that bottom mirror and shoots right out through the hole at the top.
And this is the big reveal, the aha moment. When you trace all the light rays coming from a single spot on the real frog, say point P, after that whole journey of bouncing around, they all meet up again at a new point, point J, floating in the air outside the device. Your brain sees all that light coming from point J and says, hey, there's something there. You do that for every single point on the frog, and boom, you get a complete, floating 3D image. So, mystery solved. Pretty cool, right? But what if we wanted to go from just understanding the trick to becoming master magicians ourselves? What if we wanted to design our own? Well, this is where things get really powerful, and we start talking about mathematical modeling. With a mathematical model, we can start asking all sorts of what-if questions. For instance, what happens if we change the distance between the two mirrors? Well, a model shows us that if they're too far apart, the image actually gets trapped inside the device where no one can see it. But if you get that distance just right, the illusion appears perfectly, right where it's supposed to be. And we're not just talking about a few light rays here. With a computer simulation, we can trace thousands, even millions of light paths all at once. I mean, just look at that incredible web of light. This lets us see exactly how the illusion is formed, predict any weird distortions, and perfect a design before we ever have to build a thing. So what does all this really mean? It means we've taken a curious little toy and turned it into a virtual laboratory. It becomes a playground where we can experiment, explore, and get a much deeper understanding of the physics at play. That's the power of modeling. And that leaves us with one final big thought. This was just a toy, but it makes you wonder, what other seemingly magical things in our world, from the way planets orbit to the patterns of the weather, could we finally understand? Could we unmask? If we just knew how to build the right model.